Okay, so 4.1 is about congruence, and we're going to see that when we use a composition of transformations, that we get congruent figures because of rigid motion. Rigid motion equals congruence, right? They stay the same size and shape. So if we look at these shapes, we started with a triangle ABC, and we reflected it over line L, and then we translated it over and down. And I know that AB is 4, BC is 5, and AC is 3. That means I also know that DE is 4 because it maps, right? And we have to look at our orders of letters, okay? AB is in the same spot as DE. EF is in the same spot as BC. So BC and EF are the same. And DF are the last two. And so it maps to the last two here, AC. So we know that's 3. We also know that all the angle measures. So if angle A is 90 degrees, so is angle D. If angle B is 37 degrees, so is angle E. If C is 53, so is F. And so we know that these two triangles are congruent because all the sides are congruent to a corresponding side in the other triangle, and all angles are congruent to a corresponding angle in the other triangle. So it says a 90-degree rotation about the origin maps this triangle to that triangle. Are the triangles congruent? Yes, they are, because a rotation is rigid motion. All right, and then we have figures that have the same size and shape are said to be congruent. Two figures are congruent if there is a rigid motion that maps one figure to the other. A rigid motion is sometimes called a congruence transformation because it maps a figure to a congruent figure. And then we use the congruent symbol to show that two figures are congruent. So let's read this right here. A reflection over line M of triangle ABC equals triangle DEF. So I know that triangle ABC is congruent to triangle DEF. And again, let's pay attention to the letters. A will be congruent to D. Angle B will be congruent to angle E, and angle C will be congruent to angle F. And then the same with the sides matching up. All right, so if we verify congruence, given that these are congruent, what composition of rigid motions map triangle XYZ to triangle ABC? So if we first, and I think this one starts hard, because we're rotating it about point Z, okay? So if I rotate Y about point Z 80 degrees, this is what I'm going to do. Well, X is easy. Let's start with X. 180 degrees, 1, 2, 3, 4, would be 4 this way. 1, 2, 3, 4. And that would be where X would be. Then, let me erase this just so we can see it a little better. If I go up 1, 2, 3, over 1, 2, 3, 4. I have to make that 180-degree angle, so I'm going to go down. There's my 180-degree angle, 1, 2, 3, and then over 1, 2, 3, 4. And there's my y. So there we go. And then I have a translation of 3 to the right. So the composition, T, 3, 0, and reflection of 180 about point Z maps those triangles together. All right, so this one we will do in class. On the next page, let's find out if they're congruent. So I know it has a lot of words, and I didn't erase any of them, but let's just look here and see which one of these are congruent. So the first thing I'm going to do is check side length. And what I'm going to do is I'm going to use Pythagorean theorem and say, well, this is 1 up 1 over 2. This one is 1, 2, 3, 4, 5. Let's do this in blue. 1, 2, 3, 4. And this one is 1, 2, 3, 4 over 1. Okay, so let's check these side lengths. Up 2 over 1, 2, 3. So are ABC and triangle JKL congruent? No. Oops, sorry. That's EFG. ABC, so triangle ABC, I already know, is not congruent to triangle EFG because of the side lengths. So then let's look at the other one. This is 1, oh, and that should be a 3. 1, 2, 3, 1. This one is 1, 1, 2, 3, 4. And this one is 1, 2, 3, 4. 1, 2, 3, 4, 5. So I don't even have to find the lengths of the sides of the triangle because I already know that Pythagorean theorem is going to give me that triangle ABC is congruent to triangle JKL. Okay, and we find a composition of rigid motion. We would reflect, I would reflect first across this instead of what they did. I'd reflect here. So C would be here. B is 1, 2, 3, 4. 1, 2, 3, 4. A is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And then I would move it down 3 units. So it stays the same. So the composition of rigid motions, and I'm going to write it my way though, a translation of 0, -3 is second, and first we'd have that reflection of, what is that, y equals -4. No, not y, x equals -4. Okay, and therefore triangle ABC is congruent to triangle JKL. And this is just saying that those others are not congruent, the other two, because there's no series of transformations that maps one to the other. We're going to do this next one in class. And we can, is there something that will map these guys to each other? Yeah, we can tell they're congruent, and if we reflect it, it will do that. These are not congruent. They're not the same size, we can see that. And what about this? If we translate it and rotate it, they are congruent. We will do these in class. And then I think, we'll do those in class. And that's it. So we'll see you tomorrow.